This is part 2 of lesson 4.1. We're going to continue with the examples of factoring over here. So let's go with A. So let's take out the greatest common factor. Looks to me like the greatest common factor in this case would be coefficient-wise 5, and then variable-wise A to the power of 1. And then we're going to take that out of every term by dividing every term by 5a. So 25 divided by 5 is 5, and then a squared divided by a is a. Minus 20 divided by 5 is minus 4. And then a divided by a, well, that's a to the power of 0, which is just 1. So we have 5a minus 4. And you don't need a lot of space between the brackets there. I just put more space in the event that I have to write some more. But just to make it look a bit better, I'm going to erase that and close that bracket off like this. Let's try the next one here. So coefficient-wise, it looks like our greatest common factor is going to be 1. Variable-wise, our greatest common factor is going to have x. And the degree that they all would have in common would be 2 at the most, because that's the smallest one over here. We're going to open up our brackets there and start placing in some terms. So x4 divided by x2 is x2, x squared, minus x6 divided by x2, which is x4, plus x squared divided by x squared, that's just 1. And there we have it. And then C, so let's find our greatest common factor. Coefficient-wise, it looks like it's going to be 3. Variable-wise, we have y. And then the degree we can take out, 2. That's the smallest degree there. And then we're going to do our divisions. So 3y to the power of 4 divided by 3y squared is y squared. Minus 9y squared divided by 3y squared is minus 3. And then 15y cubed divided by 3y squared is plus 5y. And again, to check that all your answers are correct, you can simply expand by distributing, by using the distributive property to see if you get back to the original expression. Now, there'll be some cases where you don't necessarily have one common variable that you can take out from all the terms. So if that happens, what we'll have to do is we'll have to group similar terms together before we can actually go ahead and factor. So we'll do an example like that together at the bottom of this table here, and then we'll do a few more examples and make sure we understand that. So here we have ax minus ay minus 5x plus 5y. And as you can see, this a has an x, this a has a y but no x, this 5 is an x with no y, and this 5 is a y but no x. So there's no common variable that we can take out. So what we're going to do is we're going to group some similar terms together. Ax minus ay, that's pretty similar because they both have a. So we'll have ax minus ay. And then the other terms, these two both have 5. So minus 5x plus 5y. And so what we're going to do is we're going to treat these as, in a way, two different groups. We have the ax minus ay group and the minus 5x plus 5y group. And I'm going to take out a common factor from each one of these groups. So the ax minus ay group, the common factor there is our a. And a common factor that we can take out from the minus 5x plus 5y group could be our minus 5. Now, let's go and take that out. So let's take out the a. So we'll have a. If you do ax divided by a, that's x. Minus ay divided by a, that's minus y. And over here we'll take out a minus 5. So we'll do minus 5. And that'll leave us with, so minus 5 divided by minus 5 is, minus 5x divided by minus 5 is just x. And then 5 divided by minus 5, or 5y divided by minus 5 is minus y. And so what I want you to notice is that what you've done here is you've actually now created this common factor for a and 5, a and negative 5. You have x minus y, x minus y. Now you can go and you can take the x minus y out as a common factor. And what's left is our a and our minus 5. A minus 5. And so you can use FOIL to expand to see if you get back to the same answer that you had up here. And if you do that, you see that you should get there. So x times a is ax, minus y times a is minus ay, x times minus 5 is minus 5x, and then minus 5 times minus y is plus 5y. And so you would carry that out, and you would see that you're on the right track. So let's try example 3 together, 3a and b. So if you take a look here, we have a common factor of b plus 4. So we can take b plus 4 out. And what's left over are 2b and our plus 5. 2b plus 5. And to see that you're on the right track, all you really have to do is expand again to see that you get back to you would get back to your expanded form that you had previously. Now this is not an expanded form. Fully expanded form, you could fully expand this and fully expand this and see if you get the same expanded form. Let's take a look at B. B is a bit more complex. It's more like the example that we did up here. There's nothing really that all the terms have in common. We have 5my plus tm plus 5ny plus tn. So let's group some similar terms together. The 5my plus 5ny, they have the 5 and y in common at least, so I'm going to put them together. I'm going to put 5my plus 5ny. And then I'll put my tm and tn together, plus tm plus tn. So I just rearranged it, keeping the same signs, but put some similarities together here. And I'm going to go and factor things out from the similar groups. So from the 5my, 5ny group, it looks like a common factor I can take out is 5y, the greatest common factor there. So I'm going to write this as 5y, brackets. If I take 5y out from 5my, that would be like this, just to show you the work. 5my divided by 5y. 5 cancels out. The y cancels out. We're left with m. Plus 5ny divided by 5y. That would just be n. And what is our common term here? Well, it looks like the common term there is simply t. So plus t, so I'm factoring out the t. If I do tm divided by t, that's just m left over. And if I do tn divided by t, that's just n left over. So now I have this common factor that I've created, which I can pull out. So I have m plus n. And then what's left over in brackets next to that, 5y plus t. And so now that I have this, I can simply, if I want to verify, expand again using FOIL and see that I end up with the same answer that I had to start off the question. So now we're going to go and take a look at how this applies to parabolas and to graphing as well. So when you have a quadratic relation in the standard form, the only thing that you really know is the direction of the opening of the parabola. And you also know the y-intercept. Now, if you factor the equation, if you go from standard form to the factored form, that gives you the additional benefit that you can figure out the zeros. So if you have the standard form, you get your opening, is it from the top or the bottom, and you also have your y-intercept. Now when you factor it, you get your zeros. Because remember that when you have the factored form, y is equal to a, x minus r, x minus s, you can use the r and the s to find your zeros. So when will the term equal 0? When will y be 0? When x is equal to r and x is equal to s. In the standard form again, based on the value of your a, so if we have standard form ax squared plus bx plus c, based on this value of your a here, you can tell if the opening is opening from the bottom or the top. And then if you want to find your y-intercept, so when x is equal to 0, your y-intercept is going to be equal to c. So you can use both of these forms to help you in sketching your parabola when you're drawing one from equations. So let's go try an example out over here. We'll start this one off. We have the quadratic relation given to us, and we know it's a quadratic relation again because of that x squared being the highest degree. We want to express the relation in the factored form. So we're going to take out a common factor that exists between all these terms here. Coefficient-wise, it looks like it's going to be, we can have -1 taken out, so -1. So I'm just doing that here, greatest common factor, -1. Variable-wise, it's x, and it seems like that's the smallest degree, x to the power of 1. So really our greatest common factor is going to be -x. And so I'm going to write this as y is equal to -x. I take -x out, so -x squared divided by -x is simply going to be x. And then minus 8x divided by -x is going to be plus 8. And so now that we have this written in the standard form, we can go and figure out what the zeros are going to be. Meaning, where's the parabola going to hit the x-axis? And so from previous lessons, we know that by looking at this, one area will be for sure where x is equal to -8, because that will make our y equal to 0. And another area is simply when you have x is equal to 0, because when you put 0 in here, that's going to be 0 times this whole term here, and that'll be 0 overall. So we have x is equal to -8, and also x is equal to 0. So we're going from standard form to this factored form here. We're able to figure out what our zeros were. Now, we can also figure out the vertex now that we have our zeros. Remember, we do our two zeros, add them together, and then divide by 2, because the vertex is in the middle there. So that's going to be -8 over 2, which is -4. So our vertex is going to occur where x is equal to -4. If we want to find what the y is, we simply plug that -4 into our equation above there. So y is going to be equal to -4 squared minus 8 times -4. And that's going to give us -16 plus 32, which is going to be 16. And that's our vertex, negative